When an electron falls from second energy level to ground state, then which of the following will produce shortest wavelength? So here we have to consider the formula that it's 1 by lambda, that's wavelength, is equal to RH z square, that's Rydberg constant, z square, 1 by n1 square minus 1 by n2 square. This is the formula that we use. Now, on the basis of this, we can say this 1 by lambda is directly proportional to z square. And on that basis, we can say that the value of lambda would be maximum for that orbital for which this z value is minimum. But in this question, they are asking that to produce shortest wavelength. It means we want to find out the transition for that particular atom or species for which this transition has the shortest wavelength. It means we need that particular species for which the z value is maximum. Let's check the z values for the given species. We have Be3 plus ion. For this species, this z value is equal to 4. Further, we have D atom. For this D atom, what's the z value? That is 1. Further, next we have hydrogen atom. For this, the z value is 1. And the next is He plus ion. The value for this He plus ion, the value of z is 2. Now, which of the given species has the maximum z value to produce shortest wavelength? That species is given here. That is this Be3 plus ion. And on that basis, I'll choose it as the correct answer. The question number 57. De Broglie wavelength associated with a ball, mass is given 132 gram, moving with speed of 1000 meter per second is, value of H is also given, that is 6.6 into 10 to the power minus 34 joule second. The value of Planck constant is given. So we know that De Broglie wavelength, that lambda is equals to H upon mv. The simple calculation is there. We have to just place the values. This value of H is already given. It is 6.6 into 10 to the power minus 34, you all know, divided by the mass, that is 132 gram. And that would be equal to 132 minus into 10 to the power minus 3 kg. The velocity is 1000 meter per second. So, if you solve this value, you will find out the value is 5 into 10 to the power minus 36 meter. So, this is the value of lambda, that is De Broglie wavelength. And that is given in option 4. And that's why the answer for this particular question is also option 4. Now, after this, it's a turn for question number 58. The ion or the atom with maximum number of unpaired d electrons is. Simple question based on electronic configuration. So here we have Ni3 plus ion. We know that the atomic number of nickel is 28, but we are talking about the species Ni3 plus. In this case, the electronic configuration would be argon 3d7 4s0, because we are forming here the Ni3 plus species. In case of nickel, the outer electronic configuration is 3d8 4s2. So here, this in case of Ni3 plus, it becomes 3d7 4s0. Further, we have chromium atom. For this, the electronic configuration is 3d5 4s1. Then we have next species, that is iron. Argon 3d6 4s2, and the last is Mn3 plus. In case of manganese, there is the half-fill electronic configuration 3d5 4s2, but we are talking about Mn3 plus. In this case, it becomes 3d4 4s0. So if we talk about the first one, in this case, The d electrons are 1, 2, 3, 4, 5, 6 and 7. How many unpaired electrons are there? 3 unpaired electron. In the next case, so let's fill the electron. 5 electrons are there which are unpaired. Then the next case is there, that is of iron. In this case, d electrons are 6, 5 and 6. How many unpaired electron in this case? 4 unpaired electron. And this is the last case for Mn3 plus ion, manganese ion basically. In this case, there are 4 electrons which are unpaired. So total unpaired electron in case of Ni3 plus ion 3. In case of Cr, there are 5 unpaired d electrons. Further, Fe, there are 4 d unpaired electrons. And in case of Mn3 plus, there are 4 d unpaired electrons. It means the maximum number of unpaired d electrons are present in the species, that is chromium atom. And that's why this is the correct answer for our particular question. Now after this, let's take question number 59. Question number 59. In which of the following options the correct order of arrangement is incorrect for the property indicated? We have different options given here. Along with the given species, there is a certain property also given. So if you look at the first option, there are 3 species are given. One is calcium ion, other is potassium ion, and third is argon. In this case, you have to check whether this order of atomic or ionic radii is correct or not. In this case, if you look at the calcium ion, this calcium ion has 2 unit positive charge, while this potassium has 1 unit positive charge. Even if you look at the atoms of these two, calcium atom and potassium atom, the size of potassium is larger as compared to calcium. Further, in case of Ca2+, there are 2 unit positive charge, which is increasing nuclear charge, and due to that effective nuclear charge, the size of calcium ion is less as compared to potassium ion. That potassium ion has less positive charge as compared to calcium ion. Further, argon is there, the noble element, as well as in this case, van der Waals radius we consider. So the size of this argon is maximum in these 3. So this is the order which is correctly given. Further, carbon, boron and nitrogen, 3 atoms are given, and we have to check the order of first ionization energy. So if we talk about nitrogen atom, this nitrogen atom has half-filled electronic configuration. That's why its first ionization energy is very much. This is correct. But if we talk about boron and carbon, in case of carbon, the atomic size is comparatively smaller. Due to effective nuclear charge. While in case of B, this atomic size is larger. That is why this is incorrectly given. This order should be, first there should be boron, then carbon, then nitrogen should be there. So this is incorrectly given. Further, we have I, Br and Cl. These 3 are halogens, iodine, bromine and chlorine, and we have to check their order of increasing electron affinity. That you can understand on the basis of electron gain enthalpy. This is the correct order of electron gain enthalpy, and that is why the nature of electron affinity is also correctly given here. This is also correct. Further, lithium, sodium and potassium, all 3 alkali metals are given, and we have to check atomic radii. So if you look at lithium, this is the smallest. We know that because the electronic configuration is 1s2, 2s1. While in case of Na, the electronic configuration becomes 3s1. Finally, for potassium, it becomes 4s1. It means it depends on the number of shell. The number of shells in case of potassium is maximum, while in case of lithium, it is least. So this is also the correct order of atomic radii. Which is incorrect here? Definitely the incorrect one is given in option 2. And this option 2 is the correct answer also. Further, question number 60. Predict correct electronic configuration for respective mentioned elements. We have the first option, that is element of group 15 and period 6. The element of group 15 and the period 6 is bismuth. And if we talk about bismuth, in this case, the electronic configuration is xenon 54, then 4f14, 6d10, that's also correct. And if we talk about this should be 6s2, it is also correct, but here this 6p5 is incorrect. It should be 6p3, not 6p5. It is incorrectly given. Even on the basis of the group number, you can also identify. To find out the group number, we just add the d electron and the valence electron also. So d electrons are 10, 2 in the 6s2 orbital, then 5 in the 6p orbital. So it should be 7. It should be the element of group 17 on the basis of this electronic configuration, but it is not so. This is the correct element of group 15 and period 6 is bismuth, not this one. So this is incorrectly given electronic configuration for the element of group 17 and period 7. If we talk about this element, this is unseptium with the atomic number 117. Here its electronic configuration is given. Xenon, then 4f14, 5d10, 6s2, 6p5. Let's check the group number on the basis of the given electron. This is 5d10, 6s2. This is correct. 6p5, it is also correct. But if we talk about this, it should not be xenon. It should be radon with atomic number 86. So on the basis of that, the atomic number would become 117. Then this would be correct. But if it is not given, this is also incorrect. Further, element of group 10 and period 5. The element of group 10 and period 5 is PD, that's palladium, with atomic number 46. That is also correctly given here. And for the sake of stability, one electron from 5s orbital is coming to the 4d1 to make it 4d10 5s0. That is why this is the correct electronic configuration of this element lead. Now the next one is element of group 12 and period 6. Here xenon is given, 5f14, 6d10 and 6s2. The clear mistake is given here. If you check this electronic configuration, you will identify that this should be 4f14, 5d10 and then it should be 6s2. So this is incorrectly given, and even I just want to tell you the name of this element also. This is element of group 12 and period 6. This is the element mercury with atomic number 80, and its correct electronic configuration is xenon 4f14, 5d10 and 6s2. This should be the correct electronic configuration. That is incorrectly given. Now, which one is correct? Definitely, that correct electronic configuration for that particular element is given in option 3 only. That's why this is our correct answer. Now let's take